This is question 1 from test 2. So I was going to go over that with you. This is copied from the solution, so when you start, you don't actually know some of those things that are labeled on the drawing. So yeah, you don't know the currents, for instance. So we'll start, and it says we're supposed to find the Thevenin equivalent, and I am going to follow the solutions as I do this. If you have another way that you want to do it, you just email me and ask, and I'll let you know what I think. So we're going to start. Let's do some KVL, and I will go about let's see, I will go about this, the left-hand loop right here. Now I said we didn't know those currents. We do know those currents when we are doing V open circuit, because for a Thevenin we need to do V open circuit. So if it's open circuit, it means that no current is flowing on the right-hand side because it's open right there. And so the only current that's flowing is the current that's coming from this current source. So it's coming up through that middle branch and then to the left and then down. And it's 2 milliamps everywhere. So if we do KVL across that, then we can say that if we label the voltage across the current source as Vs, the source voltage, as we come into the bottom side, that's minus. So that's minus Vs, and then plus 2 milliamps times 2 kiloohms. So 2 milliamps times 2 kiloohms, plus, in the other resistor, 2 milliamps times 1 kiloohm has to equal 0, or minus Vs. Milli times a kilo cancels each other out, so that's plus 4 plus 2 equals 0, or we get that Vs equals 6. So if Vs equals 6, so make this ground, make this 6. Y'all know how I do this. I say that on the 3-volt voltage source, that on the other side of the voltage source, the positive side has to be 3 volts higher than the minus side, so it has to be 9 volts. Following the solutions that you have here, if I do a KVL and I'm going around this loop, coming into the minus side of the open circuit, minus V open circuit, and then coming into the plus side of the 3-volt voltage source, that's 3 volts, and then coming into the plus side of Vs, that would be plus 6, and that has to equal 0, or V open circuit has to equal 9, which is the difference between 9 and 0 right here. So V open circuit has to equal V Thevenin, which is 9 volts. 9 volts. Okay, so now we need to find R Thevenin. There's no dependent power source. Hooray! So that means we can just do resistor simplification, and it doesn't get much easier than this one. So with resistor simplification, to find the Thevenin equivalent resistance, you make voltage sources shorts, so that 3-volt voltage source becomes a short. And this is 2 kiloohms. This is 1 kiloohm. So voltage sources become shorts, and current sources become open. So that just becomes open, so it's like it's not even there. And so from the point of view of terminals A and B, the 2 kiloohm and the 1 kiloohm are in series. So this is 3 kiloohm is our Thevenin. So our Thevenin equivalent circuit has a 9-volt voltage source and a 3 kiloohm resistor. Now it says, part B says choose RL so that the maximum power is extracted, so that was part A, so that the maximum power is extracted by the load resistor from the circuit. So maximum power happens when R Thevenin equals R load. And so that means the resistance you want to choose is 3 kiloohms. So that's the resistance you choose. And that's it. That's part B. Part C, find the maximum power. Okay, so let's put that resistor in. So we have 3 kiloohms here. This is 2 milliamps. This is 3 volts. We've got 2 kiloohms and 1 kiloohm. And we need to find the power on this 3 kiloohm, power being drawn on that 3 kiloohm resistor. So let's see, let's get, okay, well, okay, the whole point of getting the Thevenin circuit, okay, so I drew all that. The whole point of getting the Thevenin circuit is that we don't need to look at the whole rest of the circuit anymore. We know that the circuit is equivalent to it's Thevenin equivalent. So I've got my 3 kiloohm here, and that's my load, and then the Thevenin equivalent is 3 kiloohms here, and 9 volts here. And so my current, if I look at the total current, the total resistance here, these are in series, so that's 6 kiloohms. So V equals IR, or 9 equals I times 6, or 6 kiloohms. So I equals 9 over 6 kiloohms, which is 3 over 2, well, it's 3 volts, 9 volts over 6 kiloohms. And so that is 3 over 2 milliamps. So 1.5 milliamps is my current. Okay, now I need to find my power. So my power, I would have said that I would have used voltage division. I like to use that power equals IV, and I would have used voltage division to say that my voltage across that had to be 4.5 volts. But you can, because I can only ever remember one formula, but power also equals I squared R. So if you have the current like we have here, you can say the power is 1.5 times 10 to the negative 3 squared times our resistance is 3 times 10 to the third, or let's see, that ends up being I'll get a calculator here. So 1.5 squared times 3 times 10 to the negative 6 times 10 to the third. So it'll be 1.5 squared times 3 . 1.5 squared times 3 is 6.75. 6.75 times 10 to the negative 3, or 6.75 milliwatts.